Okay, let's move on to number 2. These are going to be our differentials problems. Don't freak out by all the words. Let's just read them super carefully, okay? So I have a cylinder with a radius of 2 centimeters and a height of 10 centimeters. If it helps, you can draw a picture. Blah, blah, blah. There's an error of at most 0.05 centimeters in the radius. We want to use differentials to estimate the maximum possible error of the volume of the cylinder. Okay, so this means basically that the radius could be plus or minus 0.05. So that's like some margin of error we have. And this is pretty much going to be our change in radius, which is like approximately dr. That's what a differential is, if you were wondering. So that's our differential. It's kind of like a derivative, but not quite, okay? So we're talking about the volume of a cylinder, so we should probably get that equation going. So volume of a cylinder is going to be pi r squared h, okay? And we're asked to find the maximum of something. So if you ever see that, that's your hint to take a derivative. Take a derivative. If you don't do that, we can't do much, okay? Before we do this, our derivative should not be super complicated. It should only be in terms of one variable. However, I have r squared and h. That sounds like two variables to me. Well, the problem is only talking about the radius changing, right? The differential of the radius. We're not given anything about the differential of height, so we can plug height in right away. So the volume, no matter the change in radius, is always going to be 10 pi r squared. I just plugged in 10 for the height. Okay, so now we want to take the derivative because we want a maximum. So we're going to do dv dr is going to be equal to 10 pi dr r squared. So we get dv dr is equal to 20 pi r, okay? Because the derivative of r squared is 2r, and I multiply that by the 10. Okay, so now, again, we wanted maximum possible error in the volume. So we wanted to find dv. This is the only time we're going to use this guy and call it a fraction. So up here, we're going to solve for dv. So if I multiply both sides by dr, I get dv is equal to 20 pi r dr. My answer should be a numerical value. So now I'm ready to plug everything in. Okay, my radius is 2, and we already labeled our dr as 0.05. Okay, so let's just plug it. So dv will be equal to 20 pi r dr, 0.05. You can leave your answer like this. Please don't simplify wrong if you're going to simplify. Okay, so this next one, let's see, we have a hemisphere.